Hi, welcome back. I'm really excited about your progress. You learned vectors and you still want to learn more. You want to do matrices and get going with R. That's amazing. I'm really impressed. So let's get to it and know what matrix is all about. A matrix is a two-dimensional array in R. Think of a matrix as a table you have in Microsoft Excel, where you have rows and columns. That's exactly how a matrix looks like. But the difference between a matrix and a normal table or other data structures in R is that a matrix can only have one data type, just like with vectors. Remember, in vectors, you can only have either a boolean or logical, a string or character, integer or numeric data type, but you can't have them mixed up. The same applies to matrix. You can have your rows and your columns, but with only one data type. To create a matrix in R, we need a matrix function. So a matrix function has three core arguments. We want to pass to a matrix function the data that we want to put in our table. Secondly, we want to tell R that we want to arrange this data either by rows or by column. And then I'm going to explain that in a moment. And then the third thing is we want to tell R to give us these number of rows, maybe three number of rows or four or five. So you have to specify the number of rows that you want in your table. Let's create a matrix in R. We're definitely going to start with an object that we will probably call my matrix. And with this object, just as we just learned, we need a matrix function. Now we want to put in there numbers between 1 and 12, right? So 1 to 12 is what we want to put in there. Remember, we're going to put our 1 there, and as we learned, we can put a colon and add 12 this way. So this means 1 to 12, 1, 2, 3, 4, 5, up to 12. That's what a colon means, just as we learned before. Now we want to tell R, should we arrange our data by rows or by columns? In other words, do you want your data to read horizontally or vertically, right? I'm going to choose false, and I'll tell you why I usually choose false for this, but you could choose true if you want. But whatever you do would reflect in the type of analysis you can do, and we're going to talk about that later on. And I want my data to have three rows. I'm going to go ahead and say n row equals to 3. Now if I run this matrix that we have here, we have our new matrix object that we can inspect and then see what we have in there. All right, so this is a matrix. We just created a data set with rows and columns, but as you can see, it has just one data type, and these are integers. The reason why I chose false by row is that I wanted my numbers to be arranged vertically. 1, 2, 3, then it goes up again, 4, 5, 6, then it goes up again, 7, 8, 9. I don't want my data to read horizontally by reading 1, 2, 3, 4 in that way, right? So I want 1, 2, 3 downwards, then it goes up again, because that way I'm able to arrange my data into columns and give them variable names. So if I wanted to do regression analysis or I wanted to do data analysis, I have my data arranged in columns, and these are variables, and that is why I choose false for by row. So before we get into a more practical example of how a matrix can look like, let's do a little bit of indexing. We learned how to index vectors in our previous lesson. Now we're going to talk about indexing here as well, because it's very, very, very important. Sometimes you want to select some part of your data and you have to index. So let's create a new object called index matrix, because we want to index some part of our matrix data that we have up there, my matrix object. When we want to select something out of it, remember that in vectors you had just one dimensional array, so you can just select data by specifying the position of that particular data in the range of data that you have, right? But here we have rows and then we have columns. It means if we want to select something from our table, we have to specify the row that the row that the number that we want is in, and we have to specify the column that the number that we want is in. In other words, we have to tell R that give me the my matrix object and give me data that is in row 2, for example, and that data is in column 3. So R will go to row 2 and then it will go to column 3 and select this for you, because that is what you just specified. Now if we run this code, we should see that R gives us exactly number 8. So in matrices, you want to select data by specifying the row that the data is in and specifying the column that the data is in. But that's how you do it in matrix as compared to with vectors. Now let's get into a practical example. We collected a survey of 3 tourists that visited a couple of African countries, and we asked them, how satisfied are you with these African countries? So each African country was rated by 3 tourists, and then we initially put them together using a vector. So you have a vector called Accra, Abuja, so on and so forth, Toke Gali. Now these are not just names of cities to R. These are names of objects that contains the satisfaction levels of people that rated this African country, right? So we can combine all the vectors or objects that we created as vectors into one big vector and name it satisfaction data, which is a bigger object that has all the satisfaction levels. Now, if we call satisfaction data along with everything that we initially ran, we should see that all the satisfaction levels have been put together by R into one big vector or one big object. But we are not just interested in having satisfaction levels like this. We can't do any analysis with this. So we want to change our vector to a matrix, and that we can easily do in R. Let's use an object called satisfaction matrix. So in this satisfaction matrix, we're going to create a data set that has the satisfaction levels of 3 tourists who visited Africa. Remember, we just said that if you want to create a matrix, you need a matrix function. And then the first thing you need to pass to it is the data that you want to see in your table. Now we have everything embedded in this satisfaction object. So we're going to put in the satisfaction object instead. And that is satisfaction data. And we want to specify that we want our data to read by columns and not by rows. So I'll just go ahead and then choose false for by row. And then I'll select the number of rows that I want in my data. And that's going to be 3 rows. Now, if I run my satisfaction matrix, I should see a data set. So what I have here is a data of satisfaction levels of 3 tourists that visited Africa. But as you can see, it doesn't look so nice. How do I know which satisfaction level is in which column? It means we should do something extra to make our matrix look nice. Now, remember that giving your columns name doesn't violate the fact that your matrix has one data type, right? The information inside the matrix is always going to be one data type, but we can give these numbers here names like Accra, Abuja, Nairobi, so that they represent the column names, so that they can be names of variables like in a normal data set, right? Then it's easy to understand and easy to explain. So we can append to our new data set row names and column names so that our data looks a bit nicer. I introduced you 2 new functions called row names and column names. Remember how we used the names function when we were treating vectors? We're going to do the same thing here. If you look at this line of code in line 32, we passed to it the satisfaction matrix and we made everything behave like an object, so that we can assign to it the names of the 3 tourists that visited Africa. So we want to give rows 1, 2, 3 names of these 3 tourists because they represent the satisfaction levels of these 3 people, and we pass it to the satisfaction matrix just the way we did in vectors. The row names function, you put in the satisfaction matrix, and then you assign to it the names of the tourists. So with column names, it works just like row names, but this time we are interested in giving the names of these African cities to the columns so that they represent satisfaction levels of tourists, right? Now, if we do this and then we run our matrix again, we should see some changes. We should see that our rows have changed and we should see that our columns have changed. Now, this looks great. So we have a data set with rows and columns. Rows being the tourists and columns being the cities that these tourists visited. So this is what a matrix is all about. In this lesson, we learned how to create a matrix, and then we said, well, let's go and collect some survey data and then make a matrix out of it. We did that and we realized that it doesn't look too good. We should add some row names and some column names so that it looks like a typical data set in the real world. You can also create a matrix with the Boolean or logical data type, or the numeric or the character or string data type. But in this example, I use the integer, but the same rules apply. In the next lesson, we're going to do some more examples of how to use a matrix. We'll do some basic political analysis just as usual. For now, you know how to use a matrix in R. Congratulations and see you in the next lesson.